Alright, as promised last week, we are coming back to 9.4. We're going to solve systems of equations using one more method on our calculator, and that's called reduced row echelon form. And it's just going to be a few problems. It's a nice way to, sort of a mix. You can do this by hand, absolutely. But we're going to talk about how to use it on a calculator, which is going to make this a lot easier. So if you haven't already, please set up your notes or print them out. Make sure that you've got the homework written down in your planner from the textbook, and grab your graphing calculator. If you need to pause, maybe put on the closed captioning subtitles, do that now. Alright, let's get started. So, reduced row echelon form is a way to write a matrix, and what it's going to look like is basically an identity matrix plus a little bit. So on this the first majority is going to be an identity matrix, where it's got the ones going in a diagonal, and then everything else is just zeros. And then you're also going to have one additional row, and that additional row is just going to be numbers. So it might be A, B, C, whatever the numbers could be, to the number of rows. You'll often see this written by hand with a line here, and this is an example of what's called an augmented matrix, where there's two parts basically. In terms of your calculator isn't going to put this line in. It doesn't understand that level for most of you. But this is an example. We've got the identity on this side, and then you've got a bunch of numbers here. And what that means is that if we're going to use, like we did last week, matrices to solve our systems of equations, this first one would be the first variable, so one of that variable is equal to A, with 0 of the others. None of the variables except for the second one is equal to here, and so this gives us a solution method for a lot of systems of equations. And I'll show you how to use your calculator and how to do it. The first thing you want to do is set up your matrix for the specific problem. So here we've got a big system of equations, and we're going to set up our augmented matrix that we're going to turn into reduced row echelon form. You can do this by hand, and it's called Gaussian elimination. If you're interested in doing it by hand, I encourage you to give it a try, but we live in 2020 and we have calculators, so I'm going to focus on that skill. So, just like before, we're going to start by putting our coefficients into a matrix. So we're going to start with 4, 8, -4, 3, 8, +5, -2, 1, and 12. So just as like before, these are the coefficients for our x terms, our y terms, and our z terms, all in order with our negatives. As I said, this is going to be an augmented matrix, so we're going to sort of put an imaginary line down here, and on the last row of our matrix, we're going to put the answers in. So here it'll be 4, -11, and -17. And that's going to be our complete augmented matrix. So now it's time to get out our calculator. So the first thing that we want to do is put this matrix in as A or B, or however you want to use it. So you want to go to second matrix and then edit. And this matrix here, if we're going to make it A, it is going to be a 3 by 4 matrix. And you type it in. Again, your calculator isn't going to have all this extra information, but you can definitely put in the numbers like this and enter it in there. Now, some of you are having trouble with your calculators with this next step, so whenever you're doing an operation with your calculator, go back to the opening screen that you start in, so second mode for most of you, and that's going to give you your screen where you can do your calculations, like 7 times 13. You'll do it there. That's the screen you want to be on before you start on this next step. And what you're going to do then is you're going to go back to your second matrix, and you haven't used this part of it yet. you're going to go to that middle option, which is math. Now, I'm going to erase some things. Obviously, I do not want you to erase them. So under the math heading, you're going to see a bunch of different options. You'll see the identity matrix, DET, which is determinant, augment, which we've talked about, augmented matrix. If you keep scrolling down, and it's going to be pretty low, you're going to see something that just says RREF with a parentheses, and this is reduced row echelon form. Obviously, they're not going to write all of that out on a calculator. Reduced row echelon form. And that's what you want to click on, enter. That's going to take you back to your regular screen. And we want to put in the matrix that we just used. So you're going to go back to second matrix, and you're going to use the name option. I entered it in as A, whichever one you did that 3x4 matrix in. Put that in, and then click enter. And you should get this reduced row echelon form matrix. Whoops, sorry about that. You have here your identity part, and then you have your numbers. And this is actually giving you the system of equations very quickly. Because remember, just when you add them in, this was x, this was y, this was z. So 1x plus 0y plus 0z is equal to -3. So -3 is just equal to x. Here, our 1y is equal to 1. So that's our y value. And then lastly, our 1z is equal to -2. So that's our z value. And we can write this answer as the ordered triplet, -3, +1, -2. Now, it's important for you to be able to practice the mental precision of solving these on your own. That mental exercise is good for you, but if you ever have a system of equations that you have to solve in a science class, in a day-to-day life, this is a really helpful method for you. Now, of course, there are ones that are no solution or infinite solutions, and you want to be able to recognize those because your calculator isn't going to necessarily tell you. Now, with your no solution or your infinite solutions, your calculator is going to not be able to reduce it down into perfect row echelon form. So you're going to have to recognize which of these two options you're looking at. So both of them, you'll notice that you don't have a big identity part on the left, but there's a very small difference here that means that this one is the no solution and this is the infinite solutions. And in both of these examples, it's in that bottom row, because you'll notice that that's where the difference is for these. This one's a no solution because it says that 0 of all these terms is equal to 6. So 0x plus 0y plus 0z is equal to 6, giving you the error of 0 is equal to 6, which is why it's a no solution problem. Versus in the second case, you get 0x plus 0y plus 0z is equal to 0, which is an infinite solutions problem, and that means that you have to go through your expressions, turning them into an ordered pair using x, y, and z, and substituting in terms of one variable. So we can practice to see what that will look like here. We've got our terms. If I want to write the augmented matrix, this would be 1, -3, 2 is equal to 12. 2, -5, +5 is equal to 14. 1, -2, 3 is equal to 20. So again, we've got our coefficients here, equals these numbers. Put in our reduced row echelon form for this new matrix that I've typed into my calculator. And when you do that, you get 1, 0, 5, 0, 0, 1, 1, 0, and 0, 0, 0, 1. So you'll notice here, okay, that's not in reduced row echelon form, so it's going to be one of these two, and you look for the one row, which again is the last one here with all the zeros. And here it's equal to 1, so we end up with 0 is equal to 1, so then we have a no solution answer, or DNE. So practice on your calculator. If you're interested, practice by hand. I'm always going to encourage that if it's an interest, but this is not something you'll be having to do by hand for me or for, I think, many of your teachers. So please leave comments here, or you can leave them in Zoom or in Google Classroom or by email.